We will start this problem with a square. Then we will clone this square and rotate it around the bottom right corner, therefore using the central symmetry to construct another congruent square just as shown in the sketch. Next, we will clone our bottom square and slide it to the right so that it horizontally aligns with our previous square just as shown in the sketch. Next, we will pull the line from the upper left corner of our left square to the bottom right corner of our right square, and therefore forming this blue shaded shape with the area of 11 squared units. The question is, can we somehow calculate the shaded area of this red right triangle? If you want to try to answer this question for yourself, you can pause the video right now and then come back and check your solution. Alright, so let's solve this one. So first we will label the sides of our square as S. Next we will construct a rectangle all around our sketch. And doing so, you can notice that our constructed line is actually the diagonal of this rectangle. And if we pull another diagonal, you can notice that those two diagonals will have to meet in the center of this rectangle. But since our bottom square also has the side of S, this means that the symmetry applies. Which leads us to conclude that the upper side of our bottom middle square is actually divided with the central point into two identical segments with the length that is equal to the 1/2 of the side of the square. Now let's have a look at this green right triangle. This triangle will have the height of S and the base of S plus S over 2, which we can simplify to 3S over 2. Now let's have a look at our wanted red triangle. It has the base of S over 2 and we can label its height as X. Now, since we know that both of those triangles are right triangles and we know that they share the same acute angle, we can conclude that those two triangles are actually similar. So let's use the rule of similarity. We can say that the relation between their heights must be equal to the relation between their bases. And if we simplify this, we will get the following. Now we can cross-multiply this and finally get that the height of our red triangle must be equal to the 1/3 of the side of the square. Alright, so now let's take a look at this other red triangle which forms the square with our blue shaded area. This red triangle is actually congruent to our wanted red triangle. But how do we know this for sure? Well, both of those red triangles are actually right triangles, and they share the same acute angle since they are located at the crossing lines. Next, since we know that the base of our left red triangle is equal to the half of the side of the square, this means that the base of our right red triangle will also have to be the half of the side of the square. Then, due to the angle-side angle theorem, we know that those two triangles are actually congruent, which means that the height of the right triangle must also be 1/3 of the side of the square. Now from here we have two options to solve our problem. The first option will be pure calculation method. And in this option we will first write the formula for the area of the red square as the 1/2 of the product of its legs, since this is the right triangle. We can simplify this and get that our red area is equal to S squared over 12. Next, you can notice that our middle square has the side of S, which means that its area must be equal to S squared. But the area of our middle square can also be calculated as the sum of the blue and the red areas. So, if we substitute our values, we will get the following. Here we will simplify our equation by multiply everything with 12, and we will get the following. From here we will simplify some more and finally get that s squared is equal to 12, which actually means that the area of our square is equal to 12, and we can substitute that in our previous equation. But since we know that our blue area is equal to 11, we can substitute this value and finally get that our wanted red triangle must have the area of 1 squared unit, and this is our solution. Alright, but what about the second option? Well, in the second option, we will use the pure geometry. So let's first take a look at our middle square. You can see that we have our wanted shaded red triangle. And let's duplicate this triangle around its diagonal, therefore forming this really nice rectangle with the height of s over 3 and the length of s over 2. Since the height of this rectangle is equal to the 1/3 of the side of the square, this means that we can multiply our rectangle 2 times to get the full height of our square. But at the same time, since the length of our red rectangle is equal to the half of the side of the square, we can of course mirror this to the other side of the square and therefore filling up the full area of the square. Now let's have a look at our blue area. You can see that our blue area consists of 11 of those triangles. So this means that 11 of those triangles must have the area of 11 squared units. Therefore, we can conclude that one triangle must have the area of 1 squared unit, and of course, since all triangles are congruent, this means that our wanted red triangle has the area of 1 squared unit, and again, we have our solution. So, which option do you prefer? 1 or 2? Leave your opinion down in the comment section below. And of course, if you found another way to solve this problem, please write it down as well. Of course, if you enjoyed this problem, leave a like and consider subscribing to the channel for more content like this. And as always, until next time, see you all and take care.